Hello again. This is page 2 on solving exponential and log equations. So this one, I'm going to show you how to solve in a couple different ways. My favorite way, I feel like it's easier, at least to me. That's my little opinion. The bases are not the same, but it's really easy to make the bases the same. So base 5 to the power of 4x equals 25. I can easily make that base 5. So, and I know 5 squared is the same thing as 25. Easy. Now, the bases are the same, exponents are the same. So 4x equals 2, divide by 4, x is 1/2. This is one way. If you don't like it this way because you just can't see that 25 is 5 squared, you can also think, well, if the base and the argument are the same, then that simplifies down to 1. So if I do log base 5 of 5 to the power of 4x equals log base 5 of 25. So when log base are the same, then the arguments are the same, and that's what we did in the previous page. So now I can rewrite this as 5 squared. So then I'm going to go one more step here. So 4x log base 5, and the argument is 5 squared. Now I know when the base and the arguments are the same, that equals 1. And then this guy right here, the exponent, goes in the front, multiplying. So if this is 1, this times 1 is 4x. So now I have 4x equals 2, which is the same thing that happened here, log base 5 of 5, that's just 1, and this 2 goes back in the front multiplying. I don't know. I feel like this way is easier and faster. But you also have this option here. And either way, you get the same answer. Okay. The next one, I have natural log. And I already know natural log is just log base e of x plus 2 equals 0. We're going to go ahead and rewrite this in exponential form. So e to the power of 0 is the argument, so x plus 2. And I know the power of 0 means anything raised to the power of 0 equals 1. So e to the power of 0 equals 1 equals x plus 2, minus 2 on both sides. I have x equals -1. Because this is a log equation, you need to go back and check for extraneous solutions. Remember, you cannot take the log of a negative or 0. So if I plug -1 right there for x, -1 plus 2 is +1. So the checks out, so your answer is x equals -1. Okay? Now, if you weren't listening, now you will have no idea what this check means, which is fine. You know, that's going to be funny. Okay, now applying the properties here, when I see this plus, I think multiply the arguments. So off I go. I have log base 8. Now I'm going to multiply the arguments here. And I'm going to do this in my head. So x times x is x squared. X times 4 is 4x. Minus 3 times x, which is 3x. So I have 4x minus 3x. That leaves me with x. Minus -3 times 4 is -12. Okay, that equals 1. Now go ahead and rewrite this in exponential form, just like we did on this one. So I have 8 to the power of 1 equals x squared plus x minus 12. Another quadratic function for us to solve, I need to set it equal to 0. So minus 8 on both sides. So this side is 0. So I have x squared plus x. So minus 8 on both sides. That will give me -20 there. Now I'm going to solve by factoring. So two numbers that multiply to negative 20, and same two numbers that add up to 1. So I have 5 and minus 4. Okay, so my solutions would be x equals negative 5 and positive 4. But again, because this is a log function or log equation, I need to check for extraneous solutions. So let's go ahead and plug that in. So negative 5 right there. So negative 5 minus 3, that's negative 8. I can't take the negative. I can't take the log of a negative number. So negative 5 doesn't check. So extraneous solution here will be x equals negative 5 because it didn't check. Okay, now the real solution, let's see if 4 checks. Sometimes neither will check, like we saw on the page in the bottom of page 1. So if I plug in 4 right there for x, I have 4 minus 3, that's positive 1. So the real solution here is x equals 4 because this was the one that checked. This one didn't check, therefore extraneous solution. All right. This one, I'm just going to solve it my favorite way, which is this way by rewriting them with the same base. So I can easily write 64 as 4 cubed. Now that the bases are the same, the exponents are the same, easy right there. Negative n equals 3. Divide both sides by negative 1. Then I have n equals negative 3. And this one I do not have to check for extraneous because it's an exponential equation. Let's keep going. Now the next one, I need to isolate the natural log before I can rewrite this in exponential form. So you have to subtract 6 from both sides first. That gives me 6 on this side. Divide by 5. At this point, the natural log is fully isolated. That's when I can go ahead and rewrite this in exponential form. I also know the natural log is the same thing as log base e. So log base e of 2x is 6 over 5. Rewrite this. So I have e to the power of 6 over 5 equals 2x. Now you need to divide both sides by 2. I have x equals e to the power of 6 over 5 over 2. So this is your answer. But let's go ahead and write this also as a decimal. So e to the power of 6 over 5 over 2. So x is about 1 point. Let's do 3 decimal places. 660. The other way you can plug this in is e to the power of 6 over 5 over 2. And that will give you the same answer. I'll make another video for the rest of this page.